show. I'm Martin Willis, your host, and we have a great show this evening. Actually, we have two different shows going on. The first hour is going to be with Adam Frank. He's an astrophysicist. He's got a book that came out recently called The Little Book of Aliens. We're going to be talking about his research in looking for alien life. Fascinating guy. Just had a quick conversation with him. Real excited to talk to him this evening. So if you are watching this on YouTube and you want to jump over to the next stream at 8:00 p.m. Eastern, and that's with Daniel Sheehan, the attorney. We're going to be talking about the UAP Disclosure Act that is in jeopardy right now. And so just make sure you jump over to that stream. If you're listening to KGRA Radio, then you will hear both shows back to back on this. So our our blog this week by Charles Lear is a 1973 UFO and occupant report from Baja Blanca, Argentina. A lot of things seem to happen in 1973. It's one of those years. A very well researched blog by Charles Lear. And I want to thank everyone who helps out with the show and the people behind the scenes, as well as all you who are watching and listening. And we are ready to bring in our guest, Adam. Welcome, Adam.
Hello. Hey, Martin. How you doing?
Yeah, I love the background. It's a very familiar background to me.
Very much.
Yeah, this Star Trek. I love it. So, yeah.
The old school. Old school. The original bridge.
Old school. I love the old school. The old school is what I remember. The William Shatner years. You know, I think it was only 3 or 4 seasons. I can't remember.
3 seasons. There were 3 seasons which were in infinite replay. So I was a kid in the 70s. Right. And so it would just be like, there were 2 channels that independent channels in the New York City area that played. I think it was Channel 5 and Channel 11. One at 4:00 and one at 7:00, and just every day. So there were like 2 opportunities to watch. So I watched them every episode. I've seen 30 or 40 times.
Yeah, how about that? Yeah. Yes, I watched when they came out, and my producer Donna wrote a letter because at the season 2 they were going to cancel it, and she was one of these people. It was a letter writing campaign that saved it and made it go another season, which is
that's amazing. That was like an early example of the fan support, which is now quite common. Happens with shows.
Yes. So I guess I want to. We only have an hour, unfortunately, because I feel like I could talk with someone like you forever, But first of all, just so people get to know you a little bit, can you talk a little bit about your background and what fascinated you to get into the line of the career that you are in as an astrophysicist and professor and all that?
Yeah, so I've been interested in astronomy since I was like 5 years old. I grew up in Jersey, right across from the city, New York City. And my dad was a writer, and he was really interested in science fiction. And there was he had in his library, there was a shelf that had lots of 1960s pulp science fiction magazines on them, and it was the cover of those magazines. I remember looking at them when I was like 5, and guys in space suits and rocket ships and aliens, bug-eyed monsters, and that was it for me. That's got me started being, I knew I wanted to be an astronomer like at 5 years old. And then, later on, my dad would take me to the Hayden Planetarium. I also, my mom got me a telescope. So I was into it. I always knew this was what I wanted to do. And then, as I started to get older in my teen years, I could start reading Carl Sagan. I started doing, exploring mathematics and physics, and fell in love with it, the actual doing of it. And that's been it. And so I've always, I've been an astrophysicist for 30 years, professional astrophysicist, professor for 30 years. And, I wrote this book. The whole reason that I wanted to write The Little Book of Aliens was because I wanted people, after all that time, I wanted people to see how close we are scientifically to answering that question, that we actually, through telescopes like the James Webb, in the next 10, 20, 30 years, we are going to have some kind of answer, or at least data relevant to that question. So, I've been doing astronomy forever. I've been interested in life in the universe. I've been, as well as the physics of life, just in general. What is life? Which is a strange question. So all of that has been my professional interest for a long, long time.
Excellent. There's a quote. I was going to see if I could find it for you here because I know I have it somewhere in my images, but I know I'm sure you're familiar with it, and here it is right here, and it's the Arthur C. Clarke. The two possibilities exist: either we are alone in the universe, or we are not. Both are equally terrifying, and
Yeah. Yeah. I wouldn't say terrifying, though. I think exciting in one way or the other, or compelling, or philosophically, rich and vibrant, with huge consequential for sure. But I wouldn't see either of them. I mean, certainly finding life, I don't think would be terrifying. Maybe being alone. If we were truly the only place in the galaxy or even the universe itself where there was life, that is a little freaky. And it is possible. I got to say, even though there's all those stars, I'm familiar enough, with all the things that go on, that there is a possibility that's true. I don't think so. I don't, I'm an alien optimist, but there is a route that's possible, and so that would be strange if we were the only time life ever started.
Well, it's to me, it feels like it. I know we don't have solid evidence, but it feels like it would be impossible that there wouldn't be, only because of how life can survive in the harshest of places, that they find it, and on the bottom of the ocean, or where no sunlight ever gets, and things like that. I don't know how they get their energy. I don't even know how any of that works, but it's just like life, it wants to be here really bad, and I believe it has to be a universal thing. It's just, how does it start? That's always the question.
Yeah, but this is what I love about science, is that I have the same bias. Especially microbial life, because if you look at the history of the Earth, forms about 4.5 billion years ago. By about 4 billion years or so, the crust, the magma ocean, as we call it, which eventually forms the crust, cools to the point where you're starting to have the possibility for life. And by 3.8 billion years ago, we believe that life is formed. So it's almost like as soon as the planet was ready for life formed. So, that kind of implies life is easy to make. But on the other hand, it is getting life to start. Like, exactly what happened, again, like, we have these biases that are kind of hunches, but, when you start doing the science, you also find there are ways in which it may be really, like, you may need very, very, very special conditions, in order to get it started. And that's the real mystery, because you can see from the science that there are a lot of special conditions, a lot of accidents that are required. Earth is very special compared to other planets. So it's, we just don't know. And that's what's interesting. And that's what makes the science of this so interesting right now.
Right. And, even if it was like a panspermia type situation where we were, it came through our atmosphere, or a meteorite, or whatever it is, even if it was that, it had to start somewhere. And the very first spark of life to me is a fascinating, how that all, like you said, all the accidents seem to have had to have happened exactly that way. Someday, do you think it's possible that they can create life in a lab?
Well, I'm actually involved. We have a grant from the Templeton Foundation to study, like, what we're focusing on is the physics of life. What makes life as a physical system different from, a bag of chemicals, right? And so part of that community, I'm getting used to that research community. There's what's called A-life, artificial life. So there are people who are working very hard to kind of assemble the what you need for life from basic constituents. I think that's possible. I don't know. People, like, I was just reading a paper the other day, which was like 20 years ago, and they're like, very soon we're going to have it. And it's like 20 years later, it's like, oh, well, that didn't work out. So, but in the book, I have a whole chapter on abiogenesis. So this question of how to go from a bunch of non-living stuff and then have it like rattle around in a warm pond or something and get that first replicator, get that first chemical replicator that has some information encoded in it to allow the next version of it to form, and maybe with some mutations so it's better even at replicating. That's a really, we have made a lot of progress on that. And particularly in the 1950s, the famous Miller-Urey experiment, where they first showed that with the basic building blocks, the basic kind of environment of the Earth, you could get kind of almost everything you needed to get life started. So a lot of great research, but we still don't have, still can't cross that divide from non-life to life.
Right, right. Well, first of all, I do want to say, I do want to thank you as someone of your stature and a scientist for coming on a show about UFOs. I thank you for that. And so obviously people probably want to know, and I understand, most people are skeptic, most scientists are skeptic, but I'm not going to put words in your mouth. I think skepticism is healthy in all counts. I personally, think that there's definitely something going on where something is coming into our atmosphere that doesn't make any sense in a lot of ways. And I think we may know more. But in general, have you had a semi-open mind to the possibility that we could be visited?
Listen, I'm a scientist and I'm interested in aliens. I have a very open mind, but I'm a scientist, which means this is the thing people have to understand about science. Scientists are very mean to each other. Really, the link between a piece of evidence and a claim that you want to make about that evidence, we are absolutely brutal about what we demand in making that link, right? And so we'll tear each other apart. Somebody comes with like, I've got this rock with the formation of the Earth. So I have a theory of the formation of the Earth, and this rock proves it. We will go at each other tooth and nail, about whether that claim is true, and we'll pull it apart. And the reason people will say like, well, scientists, they shouldn't be that way, or they're overbearing on it. But this is why the cell phone works. Like if we were, or this is why your aunt's hip replacement surgery didn't kill her, right? That demand, it's about standards of evidence. It's about, we have very, very rigorous standards of evidence, linking data or evidence, linking data to a claim about it. And so that, I'm totally open-minded. I also demand that kind of link. And the thing is, my work, so I work in what's called Technosignatures. I'm sure we'll talk about it. I am part of a community that is looking for evidence of life on alien planets, alien life on alien planets, where, I think that's where it's going to be. And if I made a claim, if I came out and said, look, using the James Webb Space Telescope, here's the data we have that we think proves that there is an alien biosphere on planet XYZ. I expect my colleagues are coming at me, man, with their knives out, And so for UFOs, it's the same thing. UFOs don't get a pass, right? Because it's UFOs. And so my skepticism about UFOs is what I would say is at this point, there just is not that kind of data that would link UFOs to anything otherworldly. But, so I'm sure people may be unhappy about that. And, in the book, I really try and show people what that means, why most scientists are coming at it that way. But I am all in favor. I am completely in favor of an open, transparent, scientific investigation of the UFO phenomena. And, the beautiful thing about science is it teaches you how to change your mind, right? If the data go that way, if that rigorous, super high standards of evidence, if that's where that data takes you, I'm good, because I want there to be aliens. I don't care where they are. I want to find them. Yeah. So, I'm super skeptical about what the data exists. I don't think there's any data that's really of the standards I need. But let's go look, let's have that.
Well, you hear the term that astronomy is all observational, but the difference I would say between people observing and witnessing and radar and all that, a UFO and astronomy observing something, is that it's not fleeting for the most part. Whatever it is, you can observe it, and you can, it's something you can, document. So I guess that would be, the difference between the observation when they say it's an observational science. Correct me if I'm wrong. Is that kind of?
It's also a theoretical science. Like one of the great Michael Turner, one of the great particle physicists of the last generation. He's not dead, so he'd probably be pissed off if I said that. But one of the great particle physicists of the 20th century once said to me, in a good theory, good scientific account of things, you put a quarter in and you get $1 out. right? And so anything that you do has to like lead somewhere. Like, what the amazing thing about science is like, I discover something and then I'm like, oh my God, I've seen something totally new. And then like 20 minutes later, I turn that into a tool for discovering the next thing. So that's what people have to ask. So like, observational, fleeting, whatever. The question is, have you discovered something in a way that now lets you ask the next question? And like I said, I have a whole chapter in the book where I detail what a scientific investigation of UAPs would look like, such that you'd be able to take the next step. If you actually say, for example, you went through what I was asking for, and you found that like, wow, we get very clear evidence from multiple detectors with multiple wavelengths. That thing we were looking at made a right-hand turn at Mach 500, right?
Yeah.
Like, okay, we don't have any technology that can make a right-hand turn at Mach 500. But the great thing is, what would you do next? Well, what you built, these array detectors, would let you ask the next question, right? Which is like, okay, well, is there anything we can say about the thing itself? Is there anything we can probe about the data or take new data that lets us ask, what is it made out of, right? Or, what is its reflectivity? How does it, in different wavelengths, did it reflect the same amount of wavelengths of light in infrared and in radio? So, whatever you do, if you want to know something, there are these sort of like, there's the way you set up the investigation. So it keeps leading you down the road, and you learn something, and then you learn something else, and then you learn something else. And that is what a true investigation of anything, but particularly UFOs and UAPs, would look like. Because that's what we're doing with the telescopes for the alien worlds.
When I first started the show, and really until 2017, the end of 2017, when the New York Times article came out about the Pentagon, looking into UFOs, there was no one in the scientific community, very, very few, that wanted to take a look at UAP, as they call them now, or UFOs, because of, first of all, the stigma, and secondly, that there's no funding. You can't fund something, there's no end, there's no means to an end. So how can you get funding for something where there's no real means to an end, for something that's fleeting, something that's not repeatable? But now I've seen a big turn where there are scientists now that are, I spoke to one who said, I want to be here on the ground floor, and when this whole thing breaks, because really, truly, you have to agree, I'm sure you do. I think it's one of the most important things that there is that we could possibly discover is alien and possibly intelligent life, other than ours. Besides, what happens after you die? What are the big questions?
Yeah, that's why I opened the book with that like this question of is there life in the universe is exactly like the question, what happens after you die? Because everybody's got an opinion. Nobody knows anything, and the answer would change the world, right? Would literally change our understanding of the world. So this question of life in the universe is old. I mean, you can see the Greeks arguing about this 2,500 years ago, and so that's why the first part of the book I try and run through the history. And whether you're interested in UFOs or the use of scientific use of telescopes, knowing this history is really important, because our ideas about alien life were handed to us from this long history of people arguing about it, occasionally setting each other on fire. The story of Giordano Bruno. So it's really important to understand that history, but it's important just to know that this is one of the oldest questions human beings have ever asked. And it's only now, literally it's only in the last 20 years or so, that 30 years, that we have the scientifically, because that's what most of the book is about. It's about what we can do with the telescopes, that we finally have the ability to answer that question. We finally have the capacity to look at alien worlds, which is where I think aliens are going to be, and find signatures of life, either dumb life. I always want to apologize to microbes when I say that, biospheres,
can't help
forests, microbes. So either, dumb life or smart life. We have finally the ability to search the universe, search the galaxy for evidence of life. And so that's the most exciting. This is such an exciting moment for us.
Really? And can you explain how a technosignature can, I understand that it's through light signatures of some type of chemical signatures and things like that. Can you explain how these telescopes like the James Webb will actually be able to distinguish what a technosignature is?
Yeah, so actually let's talk about both biosignatures and technosignatures, because really it's the same thing. It's just, what you're detecting is going to be different, but you should really lump up, they're evidence of life, one way or the other. So what has happened, so there's been a bunch of revolution. There's been 3 distinct revolutions in astrobiology, the study of life in the universe, over the last 30 years. The first was the discovery of other planets orbiting other stars, right? Until 1995, we didn't know whether there were any planets other than the 8 in our solar system. Don't get started with me about Pluto, okay? So, and then start. Yeah. I know. Yeah. In 1995, we discovered our first planet orbiting another star, and now we know that every star you see in the sky hosts a family of worlds. Okay. So that was revolution number 1. Revolution number 2 was actually landing on all of the different, or visiting all of the different planets in our own solar system, which taught us how planets work, taught us about planetary climate as a general phenomena, taught us about the changes that can happen in a planet. And then the third revolution was understanding Earth's own history, all the way back, Earth and life, understanding the paired evolution of Earth and life going back 3.5 billion years. Because that last one, what we've learned is that when life forms, it takes over a planet, completely changes the planet's history. Life is not some kind of passive scrub sitting on the surface. It literally is a dynamo that completely takes over the planet. And if you want an example of that, just take a deep breath. All that oxygen. The only reason the oxygen is in the atmosphere is because of life. 2.5 billion years ago, life invented a new form of photosynthesis that belched out oxygen. And that is why there is oxygen in the atmosphere. If life disappeared, that oxygen would quickly react away and disappear. So what that means is that as an example, if you could look at an alien planet and detect the signature in its atmosphere of oxygen, you will have found evidence of that life on that planet. The atmosphere constituents becomes a life detector. So how do we find that? How do we do that? One of the main ways we find exoplanets is what's called the transit method. So we're looking at a star, and we just sit and we stare at that star for a while. And eventually, if everything lines up, a planet passes between, if a planet is orbiting the star, the planet passes between us and the star. And it creates a little eclipse, like a micro eclipse. For a little bit, we see the light of the star dim slightly in a very special way, and then come back as the planet passes in front of it. So that when we see that, we're like, boom, we just discovered an exoplanet. But if the planet has an atmosphere, then a veil of gas surrounding it, then when the planet passes in front of the star, there's a brief period of time where the starlight doesn't get obstructed, doesn't get blotted out. It actually passes through the planet's atmosphere. And as it makes that trip through the atmosphere, it interacts with the chemicals in the atmosphere and leaves a fingerprint in the light. And when that light gets to us, we can kind of unpack it and see oxygen, carbon dioxide, et cetera, et cetera. And so a biosignature is something like the fingerprint of oxygen, or dimethyl sulfide, which is a chemical that only the plankton puts into the air, okay? So you discovered anything like that, oxygen, dimethyl sulfide, other things, you have found a biosignature. Now, if the planet has a civilization on it, all of its technology, the sum total of its technology, you can call it the technosphere, right? On Earth, we've got satellites orbiting. We've got at night, the artificial illumination, like the night side of the planet is entirely lit up. The atmosphere is full of chemicals that we put there inadvertently. So for example, let's take one of those, chlorofluorocarbons, or CFCs. CFCs are an industrial chemical that we used for air conditioning and spray cans. And a lot of it escaped into the air. And it turns out that was the stuff that was eating the ozone layer. Right. So we had to ban it, right? But it turns out those chlorofluorocarbons also, if a distant planet had it in its atmosphere, either because of pollution or somebody put it there on purpose, and we can talk about why, you'd be able to see that. But when you do, we wrote a paper showing how that a distant planet 40 light years away, if you looked at it with the James Webb Space Telescope, you could, in principle, detect the fingerprint of chlorofluorocarbons. And because there's no way that nature makes chlorofluorocarbons, that requires an industrial process. You see that, there's a technosphere there. So chlorofluorocarbons are a technosignature. Artificial light, we can actually see the signature of artificial illumination in the light from a planet. So that's a technosignature. If a civilization uses solar panels of any kind of solar collector, that also leaves an imprint in the reflected light off the planet that you could see from a distance. So, I am the principal investigator on NASA's first grant to study atmospheric technosignatures. And so what we've been doing is, kind of going through the list, writing scientific papers, investigating which are the best technosignatures. What should we use JWST or the telescopes that follow it to look for?
Right. And I'm sure the time use, and if you write a paper or whatever, and you get you get an authorization to look at this certain area of space, I'm just guessing.
Yeah.
But I'm sure the time is very valuable on the web, for instance. So you have to, before you even start, you have to know what you're going to look for, I imagine. And like right now, if the James Webb wanted to, could it look at a planet and see this, or is this something that you have to build up to and make it a working thing before you can even aim the telescope?
Well, the grant, what we explicitly said we were going to do in the grant is we were going to build a library of technosignatures. We were going to build a library of the actual spectral fingerprints that someone could use. Yep. Someone could use the JWST to look for. Now, what we showed in that first paper was, what we did is we took a mathematical model of a planet, put CFCs in it, watched how the climate changed, because one of the things, as I said, you might put CFCs in an atmosphere purposely because they're great greenhouse gases. So if you wanted to terraform Mars, for example, if you wanted to warm Mars up, because it's very cold right now, and so that people could live there, CFCs would be a great example. They are better greenhouse gases than CO2. So what we showed was that, so we made a mathematical model of a planet. We put CFCs in it. We watched how the climate evolved. And then we used a kind of mathematical model of the JWST and observed it. We simulated observing that planet from 40 light years away. And we found that the JWST could see it. It would be able to detect it at Earth-like levels, or even, 2 times it gets better, 2 times the level, 10 times the level, it gets even better. So we've taken the first step. Now, if we wanted to actually ask for JWST time, we'd have to write a proposal, and we'd have to then go. And again, this is this idea of standards of evidence, etc. We would have to, because the telescope time is so valuable and everybody wants it. Every hour of telescope time, there's 10,000 people who want. We have to really make a convincing case that it's detectable, because they're not going to give you time if they're like, well, maybe it might work. They're only going to give you time if you can show that if it's there, you'll see it. And we haven't gotten quite to that level yet, but we're working there. Like these technosignature studies, we're the first. Nobody's done it before because there was never any funding for it before. So the game is just getting started. Now the biosignature stuff is mature. There's been 2 decades of really detailed theoretical work and getting us ready for biosignatures. And the JWST is, it's at the hairy edge of maybe being able to see it, but it's already getting data that is relevant to this question. They're just recently, a few weeks ago or a month ago, it had some data looking at a new type of habitable planet. And they didn't see, it's not good enough to see a biosignature, but it saw other chemicals, very clear evidence of chemicals in the atmosphere that were important for us to find on the way to getting a biosignature.
Very interesting. Now, you mentioned Mars. Could that ever be habitable without a magnetosphere?
Mars, here's the amazing thing. 4 billion years ago, the red planet was blue, right? We have now conclusive evidence that the Mars was a blue world. There were either, large lakes or actually oceans on Mars. There was water, knee-deep water rushing over rocks. So Mars was Mars. That means Mars must have had a thicker atmosphere and it was warmer. It was warm enough to have liquid water on it and to keep the liquid water on it. So it's absolutely true that 4 billion years ago, Mars was habitable. Now, did life form then? We don't know. It's possible that life formed on Mars, and then, as you say, panspermia, that a meteor impact blew a chunk of Mars with some microbes in it to Earth. But that's a really open question. And until we get boots on the ground on Mars, where we can really dig into the soil and look for fossil evidence of microbes or existing microbes now, we just don't know the answer. But it's a very exciting question.
Well, I would think the latest rover that landed there isn't that all set up to find microbial life and take samples and study it and all that?
It is. But it's again, it's a first step, right? It's a hostile environment. I think, it's going to take, what it's doing is it's running along and it's digging up, taking samples and leaving them there for another mission to come pick them up. It's kind of pooping them out in a weird way.
I didn't know
so
that.
it's really, it's not a life detection experiment yet. And I also think that these rovers can do a lot, but really, if you want to answer this question, you got to have people on Mars. So let's get people on Mars and let's start the science.
Yeah, but but the radiation issue, do you think they'll ever overcome that?
That's a real issue. There's a new book out, even though everybody should buy my book, the Little Book of Aliens. There's a new book out called A City on Mars, which I want to get, where it's two authors, and they look at this in detail, all of the problems. And probably, in the beginning, all your habitats are going to have to be either buried or underground. And so, people have talked about ways of making artificial magnetic fields and such, but that's kind of really science fiction. Now, maybe I'm a firm believer that in 200, 300 years, we will have, if we don't kill ourselves from nuclear war, climate change, or AI, we will have millions or billions of people in space. We will inhabit every nook and cranny in the solar system. I believe that's our destiny, as human beings. But it's, there's going to be steps along the way. And maybe, it may make more sense. We wrote a paper recently that showed taking asteroids and spinning them up, hollowing them out and spinning them up so people have artificial gravity from the spin on the inside. Wow. That may be a much better way than dropping down a gravity well to, so maybe in the future we have, there's a lot of asteroids out there. We have, a billion people living on rotating, many, many rotating space cities. Yeah.
Wow. That's hard to even fathom how something like that could be all set up with all you need to live, all the supplies of water and food and, sustainable and all that. But interesting concepts.
Yeah. Again, there's no, it's not like any advances in physics, like getting from here to the next star or, traveling faster than the speed of light. That's science fiction, right? We don't know how to do that. We don't even know if it's possible. But building rotating space habitats is an extrapolation from the physics we have now. So it's, 300 years from now, listen to this, think about this. 200 years ago, nobody had traveled faster than 40 miles an hour, which is as fast as you can go on a horse, unless you were falling to your death from a cliff. Yeah. Right. Yeah. Right. So, and now, we travel at 500 miles an hour, 5 miles in the sky, and we're like, yeah, whatever. So, the idea that 300 years from now we'd have rotating space cities I don't think that's a huge stretch.
Yeah, I remember reading somewhere where, I forget how many hundreds of years ago, but they had a theory that if you moved faster than 60 miles an hour, you would die. Your heart would stop. Right. And I guess if you're falling off a building at 60 miles an hour, that's true. So this is a question someone posted in the chat, and I've heard people talk about this before. Would anything like that ever make any sense? And that question from Stephen is, what about a space elevator?
I want space elevators. Where's my space elevator? I love space elevators. Space elevators are the key, right? Now it's a huge technological challenge. But
Yeah.
any fan of Arthur C. Clarke, who's read, that he wrote a great book, a long, it must have been the 70s, about space elevators. So here's so what is a space elevator? The idea is, rather than have to use huge rockets to blast yourself into orbit, you have basically a cable running from orbit down to the Earth, and then you have like cars that climb up the cable, and that's how you get stuff into space. Now, the problem is, in order for this to work, the cable can't just be out, 100 miles up. The cable has to actually have a counterweight that goes way out to like 36. I'm not exactly sure how far it is, but like kind of the geosynchronous orbit or even past it, in order to keep the cable taut so it doesn't just drop down, right? These in orbit, have to be moving pretty fast in order for them to stay in orbit. So if you want something that just sits in front of, it just sits over one place, that's geosynchronous orbit. And then you actually have to have a counterweight so that it stays taut. So you actually need you need a cable that is lightweight and strong enough and can go out more than 36,000 miles. So, that's a little pushing it. But people talk about carbon fibers, carbon nanowires as being a possibility for this, because we know we can make those super strong. We just can't make a lot of them. But again, 300 years from now, that's totally a possibility. And then, you could just move stuff up and down through orbit. It'd be no problem.
One of the things when I've talked to a lot of people on the show that are either astronomers or kind of in the field of what you do, they bring up the fact that physics is the physics that we know currently. It's impossible for us. And I understand the vastness. I have a Jeffrey Bennett, who you said made an example. This is a very good thing to go by. I want to get it right though, if the sun was the size of, I think he said a basketball, and it was in Maryland, in Washington, D.C., and the Earth would be the size of a ballpoint on a ballpoint pen, and the first star would be in San Francisco. Yeah, that's kind of how he was talking about the distances. And so I understand the distances are vast, but do you think it's possible that there is some type of physics that has been learned by a high intelligence and how to travel space faster than the speed of light? Do you think it's a possibility?
Yeah. So, one of the most fun chapters of the book was I went through all the ways that, we can imagine that you could get from one star to the other, including first the conventional ways. Let's imagine that the speed of light is actually the limit that right now we know it to be. What can you do? What kinds of mechanisms do you have? And then let's extrapolate from the physics that we have and see where you can go. Because, the important thing about this, especially, if people want to think about UFOs, is you can't just wave your hands and say, well, they have advanced technology, they can do anything, right? Aliens aren't magic, right? They the universe can be explained by science. So they live in the same universe we do. So it's absolutely possible that they have science that we don't understand. Of course, that's possible. Yeah. But here's the important thing. Any science that's more advanced than our science still has to sit on top of our science. So take, for example, Newtonian gravity, right? Newton comes up with his description of gravity. It lasts 300 years. And then Einstein comes along and says, no. It's not forces. Gravity is actually the shape of space and time, right? But it's not like everyone said, well, that's it. Newton's done. What Einstein had to show was that his theory, his more advanced theory, explained and captured everything that Newton had already shown to be true.
I see.
Right? So, So any new kind of physics that involves moving faster than the speed of light has to still sit on and recover all the physics and that we know is true, and we know quite a bit, right? So that means you have to extrapolate intelligently. You have to use your imagination, constrained with what we already know about the universe, to try and move forward. And so, like in the book, as I say, there's like trying to use Einstein's theory of relativity to imagine how to go faster than the speed of light, which really means you're not going faster than the speed of light. You're warping space, right? So general relativity allows the possibility for you to take distant places in space and time and fold them together, jump from one to the other, and then unfold, right? That is a theoretical possibility. There's also wormholes, which play the same sort of role. Warp drives, there's also warp drives, which are kind of a bubble of a bubble of space-time that moves through space-time at whatever damn speed it wants. But here's the problem. So these are all theoretical possibilities. You can show in the mathematics they're possible, but the only way it works is you got to add this thing called exotic matter, which doesn't exist, right? At least, it's basically you just say like, oh, I take the equation and I'm going to add a plus sign right there with a 1. That doesn't, and I just made it up. And then you can get the equations to do what you want, but there's no, it's just purely theory. There's no, we've never seen anything like exotic matter. It's just something we invented. So, if there was exotic matter, then yes, maybe you could have faster than light travel in that kind of way. So I think it's important. Go ahead. Sorry, go ahead.
No. Go ahead. Finish it.
I just think it's important. And I also talk about quantum mechanics. And quantum mechanics is the theory of the very small. And it's the most amazing theory in physics. It's the most powerful theory we've ever developed. And really nobody understands it. And what I mean by that, nobody understands what it's telling us about about reality. And there's enough in there that maybe, you can kind of wave your hands a little bit and say like there's something in quantum mechanics that would allow you to appear, from, disappear in one place and reappear somewhere else. I'm writing a science fiction story. But that's kind of what you have to do if you want to take it seriously, as opposed to just being like, oh, they can do whatever they want.
Yeah. I've heard people say, well, they're here, so you can reverse engineer how they got here, but they're here. I don't know, what to say about that. As far as the scientific mind needing the evidence, I totally understand that. I would like to ask you how you think an intelligence, not going off the human model, but what do you think the development of intelligent life could possibly be altered by in an evolution?
Yeah, well, that's fascinating. So the last part of the book, I really engaged with the evolutionary literature. I really was looking deeply in that to try and answer that question, because we know a lot about evolution, and no matter, anything, whether the life is based on carbon or silicon or whatever, we have some general definitions. Anything we call life is going to have certain properties or certain behaviors, and evolution is one of them. Darwinian evolution is kind of more a logic than a theory, and anything that's alive is going to follow this logic. That's kind of what it means to be alive. And so when you track evolution and intelligence, what you see is, our cognitive structure, the cognitive structure that we have, the way our minds work, is really just like one teeny tiny sliver of the possibilities out there. And so this is why the chapter was so much fun to write. And it's possible, as Wittgenstein said, that if a lion could talk, you wouldn't understand what it said, right? That alien minds could be so different that we're barely living in the same world. One of my favorite movies, and everybody should watch it, is Arrival. I don't know if you've ever seen Arrival.
Oh, yes.
Yeah, so good, right? And what I love about that, so Carl Sagan had this idea that like, everybody's going to have the same mathematics. So therefore, we just meet with the aliens and we'll show them how we write the, equation for a circle, and they'll show us how they do it. And, pretty soon we'll be swapping knock jokes and, cures for cancer. And in the movie, they said, these aliens arrive, these really, really cool looking aliens too, not humanoid at all. And they send in a linguist and a Carl Sagan physicist. And the Carl Sagan physicist fails immediately and spectacularly. And it's the linguist who understands that language is not some kind of logical structure. It's embodied. It's about living in a body in the world. She breaks through, and what she finds is they are kind of living in a different world. They experience the past, present, and future at the same time. So they literally almost have a different physics in a way that they're moving through. And I just thought that movie was such a beautiful example and a warning to us that we should be so careful about not anthropomorphizing, life on other
Yeah.
planets, because the directions it can take there's so many wild possibilities that it'll be anything like us, especially like humanoid. I would argue that we're the only humanoids in the whole universe, because while legs and arms might make sense, there's so many accidents, like almost an infinite number of accidents that led to our body plans, that I don't see how you would recover all those accidents anywhere else. And Stephen Jay Gould, the great evolutionary biologist, said if you were to take Earth, you start over again, run the tape backwards, and start evolution again, you wouldn't find a single creature on Earth that looked like any of the species that are around today. And so I think that's true. We have to really be open-minded when we think about how creative life is going to be in the forms it takes.
So what are some of the things that form where we go in an evolution if it would be different? If you're talking about being on the same planet, the same development of Earth, the same gravity and all that, I don't understand particularly how it could be that much different. So I'm just curious, how his theory came up with that would be totally different.
Well, so so evolution is a battle between convergence and contingency. So convergence is the idea that you will get, physics and chemistry the laws of physics and chemistry sort of mean that life faces the same problems over and over again, and will evolve similar solutions to those problems. So for example, wings. You look at Earth and you see that wings have evolved on 3 very different evolutionary lineages. There's bats, which are mammals, there's birds, and then there's insects, right? So they all evolved wings, right? But their wings are very, very different. Legs, for example, like you can expect if you've got to walk along a surface, you'll invent some version of sticks with joints on them. But the idea is that every insect, the form of every insect, the form of a bat, the form of actually really depended on the accidents, millions and millions of accidents to get anything with, say, like the bipedal symmetry, right? That idea, or not bipedal, the bilateral symmetry. Much of life has bilateral symmetry. It doesn't have bilateral symmetry because bilateral symmetry makes some kind of cosmic sense. It's because early on, there was an accidental, mutations are always accidents. There was an accidental mutation that led to bilateral symmetry, and that preserved. Evolution is conservative. If it makes something, the next generation is going to have a version of that, and so on and so on. You could have easily got, if it had been 1 or 2 different accidents, you might have had quadrilateral symmetry, because that's totally reasonable too. And so, when a rock falls, random rock falling on some quadrilateral creature, 3 million years ago, if that hadn't happened, if that accident hadn't happened, we'd all be quadrilateral. We'd all have 4 arms, maybe in different places that had 8 joints on them. So it's that the actual form you take, you can expect arms, you can expect sticks, jointed sticks. You can expect curved surfaces that allow you that produce lift so you can fly. But the actual forms they're going to take, those are accidents. And if you ran the tape of life again, you would have wings, you would have, sticks, but they wouldn't look anything like the creatures we have today.
Isn't that something? This is someone posting here. Dirk is saying our DNA is loaded with random change, often from viruses. That's interesting. I've never thought of that or heard of that before. Is that something you're aware of?
I'm vaguely aware of it. The important thing is that the DNA is mutating all the time, right? So the 2 important things, as I described, this was sort of an interesting part in the book of seeing when I talked about this logic of life. So I tried to show people how this works. The 2 things that are important about life is one, survival of the fittest, as we all know. If the environment changes, whoever is best adapted to that environment wins in terms of reproduction. The other part is descent with modification, meaning mutation, right? So yeah, whether it's through the viruses, randomly collecting new viruses, life changes its form And so when you add those two together, that's where you get this sort of the importance of accidents, that because life is constantly changing its form, the environment is constantly changing. So you're always trying to be the best adapted to the environment. It means that you're going to get accidents being like one of the most important features of life. And that's why you just won't reproduce the same bodily forms if you run the tape of life again, or you start on an entirely different planet.
All right, now I'm going to ask you a question that most scientists wouldn't like me to ask. Is their opinion? How would you feel if you learned that you must have heard that, the claims out there, the whistleblower claims that there's crashed, UFOs in our possession in the government? And how would you feel if there was some part of the government that actually knew there was entities and was hiding it from the American public, let's just say in America alone? I'm just asking for, what would that make you feel like as a scientist if you found out, hey, they knew there's biological entities where, wherever they came from, I don't even know where they come from, but let's just say that they actually had these in their possession. Would that disturb you that that was hidden from, the science community?
Well, first of all, I'm not going to believe it until you show it. Until I, like
I
say,
understand that.
Show me the spaceship. Listen, the fact that the government hid it for 30 years, show me the spaceship. All I care about is the spaceship. All I care about is actually seeing the spaceship. Whatever, go put those people in jail or whatever. I don't care. It's the spaceship that matters. I would be so psyched to have an actual factual spaceship that I'd instantly forget everything else that happened. So, just show me the spaceship. Until then, for me, it's more stories, but show me the spaceship, I'm there. Show, that I can, give me a spaceship that I can actually take to a lab, do all the analysis of. And if that turns out to be non-human, from other, my God, this is, I'd be stoked. I'd be totally, again, the beautiful thing about science is it shows you how to change your mind. It shows you how to honestly, without shame. I've had to change my mind a number of times in science. There's no dishonor if you have those standards of evidence to show you that it's time to have a new opinion.
Yes, I think that it should be like that way in other parts of life as well, when the facts are shown. But thank you so much, Adam. It's been a real pleasure, and I hope you come back on the show. I could definitely talk to you a lot longer. Thank you so much. And the book is called The Little Book of Aliens. The Little Book of Aliens. It's in the link down below. Thanks very much.
Okay.
All right.
Take care. Thank you.
Yeah. Bye. All right, everyone. So next week we'll be back with Kevin Wright, but also right now we're going over to the next stream, which is with Daniel Sheehan, attorney Daniel Sheehan. And also later this week on Thursday, we are going to do the UAP Crossfire. I'll be hosting that this week. And that's it. We'll see you over at the next stream.